In today's session, we are going to see about how to convert an infix expression to a prefix and then postfix. In this video, we will cover about how to convert infix to prefix using a stack. So, general watch expression, we have an operands, we have an operators. So, A plus B. A and B are the operands, and then plus is an operator. So for a human, it is always you will represent it as a plus b. It is easy for our to calculate. But for compilers or for a machine, it is tough to calculate by using an infix expression. So always the compiler or machine will translate this expression into an prefix or postfix, and then it will evaluate. So that's why this is required. And then why do you require stack? Because every time when we are converting this infix to prefix, for the conversion purpose, we will use a stack. So always we have an operator precedence. We have a plus, minus, multiply, division, and then exponential. So always here, the higher precedence is exponential one, and then lower precedence is plus and minus. So when we have plus or minus or multiply or division, it will start to evaluate from left to right. Left associative. If you have an exponential, it will go from right to left. Right associative. Here you can see plus or minus a plus b. So at first a value will be taken and then b value will be taken. So it will be left associative. Multiply. So 2 into 3. So 2 will be taken first and then multiply with the 3. But here exponential means 2 power 3. Then 3 will be taken first and then the corresponding 2 value will be taken second. So this is what left associative and right associative. So then we have certain rules are there. Okay, when you use a stack. So if the incoming operator has higher precedence than the top of the stack, then push the operator into the stack. It's a general rules. We will see example. With an example, we will see all these rules. If the incoming operator has lower or equal precedence than the top of the stack, then pop the top operator from the stack and add it to the final expression, and then repeat the comparison with the next operator on the stack. If the associative is left to right, even the precedence is equal, pop from stack first and then push the new operator. So we will see this example one by one. Okay, so here is a table format we are given. So incoming has more higher precedence, push to stack. Incoming has lower precedence, pop from stack to output and then push. Equal precedence plus left to right associative, pop from stack first, then push. So we will do one by one. So here we have taken example P plus Q minus R into S plus T power U into V by W by X into Y plus Z. So the first expression going to be variable going to be P. So it's a variable, it's an operand. So straight away it will move to the postfix expression. And then plus is incoming. So in stack there is nothing. So we will push it into the stack. We will push it into the stack. So P is there in the postfix. And then here we have a Q. So in the stack we have a plus. And then straight away we can push it to the postfix. So PQ. And then now here comes minus. So now what we'll do, we'll compare this minus with the plus. Okay, minus is the incoming operator, and then in the stack we have plus is the top of the stack. Plus is the top of the stack. So now what happened here? Both are equal precedence. Both are equal precedence. Minus and plus both are equal precedence. Here you can see the precedence. Plus and minus are in the third level, and into and division are in the second level, and exponential in the first level. So both minus and plus are in the same level. So what happens over here? Equal precedence plus left to right associative. Then what happens over here? Pop from stack first, then push. Pop from stack. So what should I do? Pop from stack. So P, Q, pop from stack. So in the stack we have plus. That will be get popped up. So plus comes to the output side and then push. Okay, pop from stack first. We have done it and then we will push it. We will push it. So we will push the minus over here into the stack. So now here R is coming. So minus is in the stack and then we will push it in the output expression R. Okay. So then next one is into is coming. Into is coming. So now here into and minus. So the into have an higher precedence. Multiply have an higher precedence. So if the incoming has higher precedence, then push to stack. Then push to stack. So now what we will do? Already minus is there. So then into will comes into top of the stack. Into will comes into the top of the stack. So now here P Q plus R in the output side. So then we have an yes. So when we have a yes, straight away we can push it to the final expression. So yes goes to the output side. And then we have an plus. So now what happens over here? Incoming operator have lower precedence. Okay. In the top of the stack is what? Top of the stack is into. Top of the stack is into. Okay. So top of stack is into and then incoming operator is plus. So the incoming operator plus is having the lower precedence than the multiply because multiply have the second highest precedence where addition will have be having the third, the lowest level. So now what happens? So if the incoming has lower precedence, then pop from stack to output, then push. So you can see here, if the incoming operator has lower or equal precedence than the top of the stack, then pop the top operator from the stack and add it to the final expression. Then repeat the comparison with the next operator in the stack. We should repeat the comparison once again. Okay. So now what happens over here? So the incoming operator have the lowest precedence, then pop from stack to the output. So PQ plus RS. So into will be get popped up. Into will be get popped up. Okay. So once the into gets popped up, then what we will do? We will repeat the same step. We will repeat the same step. So only we'll be having the minus over here. We'll be having only minus over here. So why do you repeat? Because that's the steps. Then the repeat the comparison with the next operator on the stack. Repeat the comparison with the next operator on the stack. So now here plus is in the incoming operator and minus is the next operator. So both are equal precedence. Both are equal precedence. So when both are equal precedence, then what we will do? Pop from stack first, then push. So minus also goes to the output expression. Output expression. Then plus gets pushed inside the stack. Then plus gets pushed inside the stack. So whenever the incoming operator have the lower precedence, always we should pop the top of the stack and then we should repeat the same step. We should repeat the same step. We should compare with the next operator. We should compare with the next operator. That's what we keep on. So now after a plus, it's an incoming bracket. So simple. So straight away in the stack, I will push the incoming operator. Incoming open bracket. Open bracket will be get pushed. So then we have a T that goes to the final expression. That goes to the final expression. So here we have an correspondingly we have an T that goes to the final expression and then we will be having an exponential term. Okay, the T goes to the last and then So and then we have an correspondingly exponential term. So the exponential term will be pushed inside the stack. Will be pushed inside the stack. Then you can ask me that why you didn't compare? Because once a bracket gets open, after the bracket gets open, there is no operator over in the stack. So that's why I'm going to push it into the stack. Okay, so then same expression PQ plus RS, and then we have an U that straight away goes to the final expression U. Then we have an close bracket. Then we have a close bracket. So once close bracket arrives, whatever whatever in the stack, whatever operators are there, okay, until the open bracket, that will be get popped out. That will be get popped out. So close bracket arrives. Once the close bracket arrives, until an opening bracket, we have only exponential term that moves to the output side. That moves to the output side. So U and then exponential term has been moved. So in the stack, I'll be having only the plus. I'll be having only plus. So then I'm having a multiply because we in the bracket has been until this part we have completed. Until this part we have completed. So then we have an multiply. So in multiply, what happens over here? The incoming operator have an highest precedence. Highest precedence than the top of the stack. So when the incoming operator have the highest precedence, simple as that, push it into the stack. Push it into the stack. Then after that, we have an V. Okay, after into we have an V. So straight away that goes to the final expression V. Then after we have an and division symbol. We have a division symbol. So if the incoming operator have an equal precedence. Okay, when the incoming operator have the an equal precedence, then what do we do? At first, since both are since it's left to right, pop from stack, then push it. Okay, before pushing, we should repeat the same step. We should repeat the same step. Okay, so the incoming operator are equal precedence. So now the into will be the multiply will be get popped out. Multiply symbol will be get popped out. Multiply symbol has been popped out. Then what happens over here? Only the plus is remaining here. Plus is remaining. So then division is compared with the positive. So the division have the highest precedence. The division have the highest precedence. When the incoming operator have the highest precedence than the plus, then push it. When the incoming has highest precedence, then push to stack. Then push to stack. So now division get pushed into the stack. So then after that we have an W. So straight away into the output side. Straight away into the output side W. So and then we have an division once again. Okay, so already in the stack we have an plus and division. So the in the top of the stack is division. So the incoming operator also a division. So same both equal precedence. When equal precedence, what happens over here? Pop from the stack. Pop from the stack. Then repeat the same step. Then repeat the same step. So now the remaining operator is plus. Okay, so now the incoming operator division is have the highest precedence than the plus. So then push it into the stack. Push it into the stack. Incoming have the highest precedence, then push to the stack. Okay, so then we have an X. We have an X. So straight away we will give it to the final expression. we have an x. So then we have an into multiply. So once again in the stack we have an plus and division. The incoming operator have equal precedence with the division. When both are equal precedence, then pop the top of the stack, then repeat the same step. Then repeat the same step. So now here pop the top of the stack. So division has been popped up, and then remaining is only it's an plus. So now the incoming operator is multiplication, and then which is having highest precedence than the plus. So if it's have highest precedence, then push it into the stack. Push it into the stack. Then we have an y. So y directly goes to the output side. Y directly goes to the output side. And then we have an plus symbol, y plus. So now what happens over here? We have an plus and then star multiplication. So now the incoming operator has lowest precedence than the multiply. When the incoming operator have the lowest precedence or equal precedence, then what happens? We will pop it from the top of the stack. Okay. So now multiply is there. So multiply have an lowest precedence. Okay. So now what do? We will pop it from the stack. So it will go to the output side. The plus, the incoming operator is plus. The plus is having the lowest precedence than the multiply. Plus is the lowest precedence. Compare with the top of the stack is multiply. So when it's have the lowest precedence, pop from stack to the output, then we should repeat the same step. You can see here the steps. Pop the top operator from the stack and add it to final expression. Then repeat the comparison with the next operator on the stack. So we should repeat once again. So now what happens over here? Multiply goes to the output side. Then what happens over here? The remaining is positive. The remaining is only positive. So now here, both are equal precedence. Both are equal precedence. When both are equal precedence, what happens over here? Pop it from the stack. So we have popped it up. So there is nothing remaining left in the stack. So then there is no need of any comparisons. So then we can push this plus into the stack. So then we have an z. So z goes to the final expression. So then only one thing is remaining in the stack, that is a positive, because the expression has been over. Once expression is over, whatever left in the stack that can be popped to the output side. Okay. So we have an z and then we have an plus. So nothing is in the stack left. So the final expression is infix to uh, postfix. This is the final expression. This is the final expression of conversion into infix to postfix. So these are the rules. Okay, these are the rules we have. So the title I have given wrong. So it should be postfix. So infix to postfix. Okay, so in the infix to postfix expression conversion, always we will see three rules. Okay, if the incoming operator have the highest precedence, then we will straight away push it into the stack. If the incoming operator have the lower precedence or equal precedence, then pop the top of the stack and then repeat the same step with the next operator. Okay, so, and then we'll go one by one. Okay, if the bracket is there, open the brackets, put into the step, push it into the stack, and then perform the same operation. Once close bracket arrives, whatever operators are there in the still the open bracket arrays in the stack, pop it everything. So this is the final postfix expression. Postfix expression for the given equation. So in the next session, we will see how to convert in this infix to the prefix expression. Okay, thank you.